There are two parts to the mill. The first part that I'll talk about is the head. The head consists of the spindle forward reverse switch, the e-stop button, the RPM adjustment dial and readout, the gold box on the left side is the power drawbar in and out buttons. Next is the digital scale, the coil handle and lock, and over to the right is the Axis DRO control panel. The second part is the table and the knee. That part consists of the Z power feed and hand wheel, the Y-axis hand wheel, the table which the vise is mounted to, and the X-axis hand wheel.
Open the bottom drawer using the notch on the side. All the tools you'll be using are in this drawer, so leave it open.
Familiarize yourself with the hand wheels on the mill before you start machining. The X-axis hand wheel is located on the right side of the table. Extend the handle on the hand wheel and turn the wheel in both directions. Notice the number changing in the X on the DRO when turning the hand wheel. The Y-axis hand wheel is located on the front of the machine. Do the same with the Y-axis hand wheel as you did with the X. The Z-axis gearbox is located to the left of the Y hand wheel. It has a power feed option to go along with the hand wheel. Using the power feed saves time when moving the table up and down. To raise the table, lift up on the lever on the left side of the gearbox. Notice the number getting smaller in the Z on the DRO. To stop the feed, put the lever back in the middle where it started. To lower the table, push the lever down. Notice that the numbers are getting larger in the Z on the DRO. The Z hand wheel is generally used to make finer adjustments, such as setting the tool to the part, as you will see later in the video. Let's transition over to the DRO itself. The buttons on the DRO that you will be using are the X, Y, and Z, the numbers, and ABS set. Please do not use the arrows just to the right of the screen. The video identifies these arrows with a red box with a line through the middle of it. If you accidentally press one of the arrows and a green box appears on the screen, please notify staff. We will get you back into the proper screen. Failure to do so could result in damage to the part, the tool, and the machine, or all the above. Measure the diameter of your stock with your caliper if you haven't done so already. You should have this measurement written down on your drawing from the lathe portion of the video. Before placing the part in the vise, clean the jaws of the vise with a rag. When finished with the rag, place it in the toolbox. Do not leave the rags on the machines. Take the parallel, place it inside the jaws of the vise. Now place your part on top of the parallel as shown, with the boss to your left. Leave approximately 1/4 inch of the part sticking out of the right side of the vise for measuring. Secure the part in the vise by turning the vise handle clockwise until the jaws are tight against the part. Tighten the handle firmly. Check the parallel under the part to see if it is loose. If it is, grab the dead blow hammer and firmly tap the part until the parallel is tight. This will ensure that the flat being created will be parallel and not tapered. Locate the collet into the spindle by lining up the keyway on the collet with the key in the spindle. Place the end mill into the collet, holding at the bottom of the shank with your index finger and thumb on your right hand. Hold the collet up when holding the end mill in place. To the left side of the mill head is a gold-colored box with 2 buttons, labeled in and out. Firmly press the in button. This will activate the power drawbar to tighten the tool in the spindle. Be aware that the tool will rotate when the drawbar tightens the tool. Adjust the quill stop by turning the stop on the threaded rod up or down. It also has a quick release button to bypass the threads. Just push the button and it will slide up and down. Set the stop at least an inch or so from the top. Once the stop is where you want it, unlock the quill, bring the quill down to the stop, and lock it again. Now turn on the digital scale and zero it. Turn the spindle on by turning the switch to the forward position. Adjust the RPM dial until the readout reads 1000 RPMs. Turn the Z hand wheel clockwise to raise the table. Raise the table until the tool lightly touches off on the top of the part. Once the tool is touching the part, use the X hand wheel to move the part away from the tool. Now shut off the spindle. Press the Z on the DRO and type in the diameter of the part you measured earlier. In this case, I'll enter 1.01 and press Abset. Raise the table until the DRO reads 0.980 in the Z axis. Note, please do not take more than 30 thousandths depth of cut at one time. Add cutting oil to the part and turn on the spindle. Use the X hand wheel to slowly feed the part all the way across the end mill. Note, the slower the feed rate, the better the finish will be on your part. Move the part away from the end mill and shut off the spindle. Use a rag to wipe away any chips left on the part and remove the rag from the machine. Now take your caliper and measure from the flat you just milled to the bottom of the part. Compare that number to the number in the Z on the DRO. If that number is off by more than 2 thousandths, change the DRO to the number you measured with the caliper. Now raise the table with the Z hand wheel until the Z reads 0.950. Remember, no more than 30 thousandths depth of cut at one time. Add cutting oil and turn on the spindle. Use the X hand wheel to feed the material across the end mill. You may notice a lip of material left on the flat at this time. This is perfectly normal. That is because the flat is wider than the diameter of the end mill. You will have to offset the Y-axis and feed it back the other direction to remove all of the material. Move the part away from the end mill and shut off the spindle. Wipe the part clean with a rag and remove the rag from the machine. Measure the flat and compare it to the number on the DRO to see if you are still on track. If all is good, use the Z hand wheel to move the table up until the DRO reads 0.938, which is the finished dimension on your print. Add cutting oil and turn on the spindle. Repeat the milling process as stated earlier using the X hand wheel. This is your finished pass, so use a slower feed rate to create a good finish on the flat. Once the first pass is complete, offset the Y-axis and feed the X-axis in the other direction to remove all of the material. Move the part completely away from the end mill and shut off the spindle. Use a rag to wipe the part free of chips and remove the rag from the machine when finished. Now measure with the caliper. The print calls for a dimension of 0.938 with a tolerance of plus or minus 0.01, which means if your measurement falls between 0.928 and 0.948, you are good. Remove the part from the vise. Clean the vise, parallel, and part with a rag. Place the parallel back inside the vise and place the part on top of the parallel with the milled flat up against the solid jaw as shown. Leave approximately 1/4 inch of stock sticking out of the right side of the vise for measuring and milling to length later. Secure the part in the vise and use the dead blow hammer to firmly tap the part until the parallel is tight underneath the part. Since the DRO should be set fairly close from the first flat, lower the table with the Z hand wheel until the DRO is at 1 inch in the Z axis. Remember, add cutting oil to the part for each cut. Turn on the spindle and use the X hand wheel to slowly feed the part all the way across the end mill as you did with the other flat. Move the part away from the tool and shut off the spindle. Use a rag to wipe away any chips left on the part and remove the rag from the machine. Use your caliper and measure from the flat you just milled to the bottom of the part. Compare that number to the number in the Z on the DRO. If that number is off, change the DRO to the number you measured with the caliper. Bring the Z up no more than 30 thousandths depth of cut at a time. In this case, I'll bring the Z up until the DRO is at 0.970. Now continue milling the flat. Remember, the flat will be wider than the end mill, so you will have to offset the y-axis and feed it back in the other direction to remove all the material from here on out. For the finish pass, raise the table with the Z hand wheel until the DRO reads 0.938. This is the finished dimension on your print. Add cutting oil and repeat the milling process as stated earlier using the X hand wheel. This is your finished pass, so use a slower feed rate to create a good finish on the flat. Once the first pass is complete, offset the y-axis and feed the x-axis in the other direction to remove all the material. Move the part completely away from the end mill and shut off the spindle. Use a rag to wipe the part free of chips and remove the rag from the machine when finished. Measure with your caliper. Your print calls for a dimension of 0.938 with a tolerance of plus or minus 0.01. If your measurement falls between 0.928 and 0.948, you are good. Lower the quill stop so the tool is below the bottom of the part when the quill is extended. Lower the quill to the stop and lock the quill. Position the table so the side of the end mill will touch the end of the stock. Turn on the spindle and leave the RPM set at 1000. Use the X hand wheel to slowly move the part towards the end mill until the end mill lightly touches the part. Now move the part away from the end mill by rotating the Y-axis hand wheel counterclockwise. This will bring the table towards you and the end mill away from you. This puts the end mill in the climb milling position, which I will explain later. Shut off the spindle and measure the length of your part and enter that number into the DRO in the X-axis. Use the X hand wheel to adjust your depth of cut. No more than 30 thousandths depth of cut at one time. Add cutting fluid to the part and turn on the spindle. Slowly turn the Y hand wheel clockwise to remove the material from the end of the part with the end mill using the climb milling method. Climb milling is when the direction of the feed is going with the rotation of the tool and is the preferred method when using the side of the end mill. Once the tool is all the way across the end of the part, turn the Y hand wheel counterclockwise to get the end mill in the climb milling position again. Shut off the spindle. Now measure the length of your part with your caliper. Compare the caliper with the dimension on the X and the DRO. If that number is off, change the DRO to the number you measured with the caliper. Add cutting oil to the part and continue milling the part to length using the climb milling method. As I stated earlier, no more than 30 thousandths depth of cut for each pass. If you have questions about climb milling versus conventional milling, please see staff. We'll be happy to answer your question. Periodically shut off the spindle and measure the length to make sure the DRO and the caliper are consistent. If you need to adjust the DRO, now is the time to do it. Continue climb milling until you reach your finished length. In this case, our finished length is 3.125 for the alpha part. After your final pass, shut off the spindle and measure the length to be sure it's within tolerance.
If the measurement is within tolerance, raise the quill and lower the table. Lower the table to give yourself plenty of room for the keyless chuck, the drill, and the tap. Once you have about 6 inches of space, stop the table. Make sure the quill is all the way up and locked. With a rag in your hand, hold it below the end mill and firmly press the out button. Load the keyless chuck by aligning it in the spindle and firmly pressing the in button. Now tighten the edge finder into the keyless chuck as shown. Lower the quill stop to give yourself enough room.
We will be finding the 0 in the X-axis first. Bring the quill down so the spring portion of the edge finder is alongside the end of the part as shown. Turn on the spindle and turn the RPM dial down until the readout is approximately at 800 RPMs. The edge finder should be running out at the bottom. Now move the X hand wheel slowly so the part makes contact with the edge finder. Keep adjusting the hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the part. 0 the X on the DRO. Now move the edge you just found to the center of the spindle by the radius of the edge finder, which means move the X hand wheel until the X DRO reads negative 0.250. Visually look to see if the edge of the part is in the center of the spindle. If so, 0 the X axis. You just found the X origin. Now we need to find the Y0. We will be finding the edge of the solid jaw that the flat is up against. Bring the quill down so the edge finder is inside the solid jaw. Make small adjustments with the Y hand wheel as the edge finder makes contact with the solid jaw. Keep adjusting the hand wheel until the runout of the edge finder gets smaller and smaller and slightly breaks the other way. Raise the quill so the edge finder is above the vise. 0 the Y on the DRO. Now compensate for the radius of the edge finder. In this case, Y would read 0.25 on the DRO. Make sure the edge you just found is in the center of the spindle. 0 the Y in the DRO again. Now the Y axis is set. The key to using the edge finder is to move the edge you just found toward the center of the spindle by the radius of the edge finder. Take the edge finder out of your keyless chuck.
Load the spot drill into the keyless chuck. Bring the spot drill down till it touches the top of the part. And 0 the quill readout. Turn on the spindle and adjust the speed to 1000 RPM. Use the spot drill to a depth of 50 thousandths of an inch. Now remove the spot drill and put it back in the toolbox. Grab the number 7 drill and load it into the chuck. Touch the drill to where you just spot drilled and zero the quill readout. Add some oil before drilling. With an up and down motion, peck drill the part until you reach -0.7. Remove the drill and put it back in the toolbox. Grab the countersink and load it into the chuck. For the countersink, lower the RPM to about 300. Use the countersink to create a chamfer around the hole. Remove the countersink and put it back in the toolbox.
Place the square end of the tap into the tap handle with the corners locating into the V-jaws. Now tighten by turning the collar on the tap handle as you would a keyless chuck. Take the dead center and mount it into the keyless chuck. You may have to lower the table to make room for the tap and tap handle. To lower the table, place the Z power feed lever in the down position until there's room to accommodate the tap and tap handle. Once the table is in position, place the lead of the tap into the hole and move the quill down to line the dead center with the drilled center on the tap handle. Add cutting fluid to the tap. Keep light pressure on the quill handle when tapping. Do 3 half turns clockwise to create threads and 1 half turn counterclockwise to break the chip. Remember, retract the quill slightly when breaking a chip. This will allow room for the tap to move back. Repeat the 3 half turns clockwise and 1 half turn counterclockwise until the tap reaches the bottom of the hole. You will know when the tap is at the bottom. It will be harder to turn. Do not go any further at that point, otherwise you could break the tap. Once you've reached the bottom, retract the quill and remove the tap. Notice the chips in the flutes of the tap. These will need to be removed before using the tap again. Place a rag over the hole and blow the chips out using the air blast located at the machine. Now check the thread depth. If the nut on the thread gauge bottoms out on the flat of your part, the depth is good. In this case, the threads need to be deeper. There might have been chips at the bottom of the hole when tapping the first time. That would prevent the tap from going all the way to the bottom. So to fix this, run the tap back into the hole and try to create a couple more threads. Add cutting fluid and repeat the tapping process until you feel you reach the bottom of the hole. Remember, use the 3 half turns clockwise and 1 half turn counterclockwise method. Once you've reached the bottom, retract the quill and remove the tab. Use a rag to cover the hole and blow the chips out using the air blast located at the machine. Now check with the thread gauge again. Make sure the nut on the thread gauge is seated on the flat of the part.
Using the file in the forward direction, remove any sharp edges from your part. Once completed, take your measurements and fill out the part drawing. If you're unsure how to do this, follow along to the video.